Right, so hi guys, I'll be recording this contest called ByteRace by CodeChef. So this is, I guess it's only it's only rated for the Div 2 participants, so it won't be rated for me. And yeah, I'll try to share most of my thought process during the contest. So yeah, you can expect some commentary in this video. Also, there is some cool cash prize as well in this contest. I'm not aiming for that, but yeah, you don't find that generally on CodeChef so much. And I think it's being conducted by IIT Pune because they have some special prizes for the winners from IIT Patna. Yeah, it's not IIT Pune, it's IIT Patna. Okay, yeah, so wish me luck. Let's see how this one goes. If it is rated for Div 2, I'm expecting a little easier problems in this one. But yeah, let's see. Recording is on, alright. So it's a 2 hour 30 minutes long contest. I was expecting 2 hours, not 2 hours 30 minutes. But yeah, you have around 7 problems here. Should be less than or equal to 1. Okay. This should be less than or equal to 1. Less than or equal to 1. Find the minimum number of weapons a kit cyborg can have when all the N weapons are distributed among them. Okay, so like, isn't it the max? Calculate the minimum number of weapons a kit cyborg can have. Yeah, so basically, I guess you should simply divide that. We have N and K, so we can simply divide N by K. I guess that should give you the maximum answer because you're obviously distributing it, and yeah, I guess N by K is the answer for this one because obviously the maximum one has to be only greater than or equal to the minimum by 1. So you can have like K, you can assign A to all of them, and then you can have something like A plus some, and the maximum one can only have A plus 1 then. So that will be the part that will remain from the modulus. I'm submitting this one. I'm pretty sure this should work. Yeah, let's see. Okay, this one is correct. Let's see the second one. In the new world, we also have a new system called the system assigns point to each Latin lowercase alphabet as follows. A is assigned 2 to the power 0. B is assigned, okay, fine. 2 to the power 25. Cyber string is a sequence of lowercase Latin. Okay, now the total score is the sum of points of characters. You will be given 2 and K construct cyber string X of length n with total score K operand -1 if it is not possible to form the cyber string. Okay, we can't have 0 here, right? So we only have 2. So yeah, it has to be some binary string. Okay, fine. Let's do. Okay, so yeah, all of them have to be powers of 2, right? And you cannot have 0 anywhere. Yeah, the minimum character is A and the maximum character is 5. I mean, it is Z and it subtracts 2 to the power 25 from it, right? Yeah, exactly. So we also cannot have a DP here, like an N to K type of DP won't work. So what else can work here? Also, there is one thing that, a Z can be replaced by two Ys. That is one thing. So yeah, a Z can be replaced by two Ys, which is great. So yeah, why not only construct it on the basis of Z first? And then you can split it, like try to get the maximum characters, and obviously those we will be able to split them, right? Yeah. So it is not possible only when you have, like, for example, he wants to construct, you have the input as N and K, for example, he wants to construct total score of K, right? K cannot be less than that, I guess, yeah. So this simply works here. I can replace every Z by two Ys in that case, if you're not able to form it. Yeah. So why not first form it with the basic Z's, and if the length is, you're not able to form it, then we can obviously increase it. Yeah, we can increase the length by 1 at any point. So only when K is less than N, the answer won't be possible. Okay. Okay, a lot of typos. If N is greater than K, here C out -1. Then we'll try to find the answer. So we'll have string. Yeah, this is our string right now, and we want 10 to the power 5 characters into it. Yeah, so I guess having some vectors will be better, or let's just have int here while K is greater than 0. Yeah, n to the power 7 हमारे पास. 10 to the power 7 is like, yeah, 2 to the power 25 से छोटे ही है वो. Yeah, 10 to the power 7 is less than 2 to the power 25 here. 5 into 10 to the power. Okay, so yeah, it is obviously greater than 2 to the power 25, so yeah, we can do that. We can take out the maximum power of 2 that divides it. Let's just debug this one. And let's just see. So here, for example, we have 2. That can be split into AA for sure, yeah. Then here we have 5, so we have 2 and 0, yeah, that's fine. So what else can we do? Now we'll always have the maximum ones first, yeah. 2 to the power 25, and this is definitely greater, so it won't work, so that's fine. So what we need to do is we need to bring the length of the vector to n, right? Yeah. So this is what we'll do. While length is less than if we have 2 here, 3, that can be split into 0, 0 and 0. Can it be split into 0, 0, 0? Can be split into 2. Yeah, that's fine. So how do I actually decrease the length? I can think that can be done by multiset. But yeah, then how will I remove them? Why not just form a vector here? Multi-set won't work because we also need the count. Let's see. m1.end, yeah. We'll do previous of m1.end and we'll remove that. Then what we'll do is m1 we'll have this. So what will print of is this is working fine actually, but I'm not sure of its complexity. Like I'm not pretty sure like what is the complexity here of erasing. If it is log n, then this is fine. Then this is totally fine, I would say. Let's just try to submit this on, like I'm sure of the logic here, but yeah, the time complexity, it only depends upon the time complexity here. Like if n is not too much, then also it's fine, but like for 10 to the power 5 it can exceed the time limit. Okay, so there seems to be a wrong answer here. I'm submitting on the right problem. CAB. CAB is the problem that I'm submitting on. Yeah, that's fine. ये log 2 का भी केस हो सकता है थोड़ा यहाँ पर. Multi-set. ABD. So we actually removed that one. Yeah. Let's just find out the multi-set here. So first we have this. What we did was we split it into two parts. Mm. 64 plus 32 plus 16 plus 8 plus. Okay. अब तो लाइक हाँ जब ज़्यादा ही एक्सीड कर जाए तो भी नहीं हो सकता ना. 2 to the power. So you know, like every answer is not possible with them, right? Yeah. Like आप exact answer निकाल लो. For example, मुझे ये सेम चीज़ अगर एक में कंस्ट्रक्ट करनी होती तो it wouldn't have been possible ना. हाँ like मुझे आंसर मिल जाता but that wouldn't have been the correct answer. We cannot do it in one length. Yeah, if length is greater than equals. Yeah, I guess I'm missing out this one. Yeah, I guess now it is fine. I guess now. So this was an edge case that I was missing out. When length is already greater than n, then it does not work out. Yeah. Otherwise, I think it's fine. Let's see. Already a 63 number of people have solved it. Yeah, so that's fine. So let's see this one. N series in this world 1 to n, that is right the theorem. This should be Supremely okay. Infinite stretches of AC need that okay in one each state then it should just two cities L and R. He starts at city L and moves down the road towards right side till he reaches the city R. In city L he destroys one statue. I minus L plus 1. Okay, so yeah, that is
अरे क्या बात करते हो गए कब से हम मुझे लगा रेसिडेंट
okay. So there are a lot of queries here. Now, how do we process this? Some type of lazy propagation is what I'm thinking of here. Then it will be q log n type something type of solution. So yeah. Or what I can do is like if I put a 1 here and a minus 1 here, then I only add a 1 here in all of this. And then I added 2 in all of this. Like what if I apply the whole thing to a suffix? I think a suffix would work. Applying it only to a suffix is something that can work here. For example, I have this array, so if I apply the operation, let's say the operation is something like this, that you have to apply it till here. So I can put a 1 here, I can add a 1 here, that when 1 is there, a 2 will be added here, a 3 will be added here. What I can do is, when I just, let's say this is 5, so I can put a minus 6 here, yeah. So what happens is like, yeah, we have 1 2 3 and we'll add it to this, so this will become, now what is the value that should be added? That is the whole thing now. So we put a minus 6 here, 5 here, so I put a plus 1 here, and then I do 6, so it becomes 0. Yeah. How do I apply some operation in the whole part of this? like यहाँ पे मुझे range तो चाहिए नहीं, I only want the point values after all the queries. The thing is that we have to do it after all the queries. So at 1 2 3, so I put a 1 here, and I put a 1 in all of these. And I put a 1 here. What I do is when I'm here, I add the prefix also. Yeah, so I add the value here and I also add the prefix here. So, and if I put a minus 1 here, that there are 1, 2, 3, 4, 5. This will become 5 plus minus 5. This becomes a 0 because I'm not putting anything here. Suffix, let's say 0, so I put a 1 here, then I put a 2, then I put an n, then here I put minus n. So what happens is it will add n and then it will add minus n. Yeah, this is 0 basically. And then he tells me that 1 is also added here. So how will that be accommodated? It will become put a range update here and add 1 in all of these. Adding a minus x to all of these is not necessary. Adding a minus x to only this one is fine, I guess. So we need a range update here in this whole range, and yeah, then I need this value has to also be added to this. Yeah, so I guess it works. I guess this thing should work. Then I'll take the whole prefix sum as the answer. लेफ्ट से we can update in the bit. So yeah, I have this now. That is fine. Now what else do I need to update? need to update r minus l plus 1. Yeah, this is the value that needs to be updated, and also need to update. Yeah, let's see. I don't know, I just have a very strong feeling for this one. Should be correct. Okay, so there. Okay. Okay, so we have in 10 and Q, 1 and 3, 1 and 2, 4 and 5. I don't know what is not working out here. Okay, there is a 0. It should be 1. Exit code 3. Let's not update only. Let's try by doing this. Okay, I got it. It has to be something like this, yeah. Okay, so it is saying 24312. Yeah, so what I did was I updated it here from idle to length plus, and I updated this. Then from r I updated r minus l plus 1. One, two. Okay, so I will need it till that point. One and one. This should have been minus and this should have been plus. Yeah, that's fine. ये नहीं कर This should give around to them. Okay, another wrong answer, or like is it the first one? Okay, so I made only one. Yeah, this one is fine. I don't know why it did not get submitted that time. Okay, let's see. Fine, great. Mm. This is probably have to calculate minimum of BI to BJ. Okay, so like calculating this is like simply order of n square into log of n. Yeah, n square into log of n. This is the solution that I'm getting right now. We reduced. Let's say n square. Let's say we have that law practiced. Okay, it is an ascending order. This to this, this to this, this to this. Yeah, this has to be added. Single value gets added how many times? We need to have something like ending fixed है. इसके आगे आप ending point इसके आगे नहीं रख. बस दो रेंजेस हैं कि भाई आप यहाँ से स्टार्टिंग पॉइंट चूज़ कर सकते हो, यहाँ से एंडिंग पॉइंट चूज़ कर सकते हो। Yeah, so if you pick the starting point from one of these ranges, then you get this whole thing, right? Yeah. But if you pick the starting point from here, for example, if you pick this point, you only get these values. If you pick this point, you only get these values. This point, if you pick this point, you get none here. So clearly for this point you get 0, for this point you get 1, point you get 2, point you get 3. Yeah, that's fine, that's fine, that's fine. So for all of these, like you subtract, for this you subtract how much? You'll get n minus y from here, n minus y plus 1, then you get n minus y plus 2, and from this point you get n. This is what you get, yeah. So what you will do is you'll find the intersection point, and intersection point से हम क्या करेंगे ना, हम इसमें से intersection points का square subtract कर देंगे, right? So what we are doing is we are basically calculating इस min value के लिए हमें कौन से पॉइंट, starting point fixed है कि भाई यहाँ से यहाँ तक चूज कर सकते हैं, ending point is also fixed like here. Then what you do is, like this will be n log n type something. So what you do is you find their intersections. Right, like मतलब this ending point होगा तुम इस रेंज में यहाँ फाइंड कर लो, सिमिलरली इसका एंडिंग पॉइंट होगा तुम इस रेंज में यहाँ फाइंड कर लो. So you have this and you have this. So you have n into m minus this summation. That many times you add that many value. Yeah, this seems to work out. Are the values also distinct? Let's just see. काफ़ी heavy implementation है, but I'm hoping this one gets right. like ये भी हो जाए तो काफ़ी है, 1 घंटे में इम्प्लीमेंट हो जाना चाहिए. नेक्स्ट स्मॉलर का वो निकाल लेते हैं एक बार कोड. ओके हाँ. एंड नेक्स्ट पता चलेगा ना दैट टाइम. एक बार नेक्स्ट स्मॉलर चला के देख लेते हैं. ये हो जाएगा. लाइक मुझे आइडिया काफ़ी सीधा लग रहा है इसका. तो डिबग करते हैं नेक्स्ट स्मॉलर को. चलेगा. ठीक है. 3 के लिए स्क्रीन 4 over 4 right. Yeah. So ठीक है. Cool. Yeah. S1 dot top is greater than a at I. इसको बंद करो यार पहले तो एक बार. स्मॉलर है नहीं भैया. ठीक है. Cool. So this is fine. Now what we'll do is हम क्या करेंगे, हम नेक्स्ट स्मॉलर से जो बड़ी प्रीवियस स्मॉलर से वो इंडेक्स बड़ी होनी चाहिए, प्रीवियस स्मॉलर से वो इंडेक्स बड़ी होनी चाहिए, नेक्स्ट स्मॉलर से वो मैंने सर उसके प्रीवियस स्मॉलर से लिस्ट चाहिए। क्या चाहते हैं, हम चाहते हैं इस वाले से ग्रेटर हो। ओहो क्या परेशानी हो गई? ओहो -1। ओके सो ये करें -1 क्यों आ रही है? Like if you see 1 here, okay, 10 पे नहीं 1 से कुछ भी सिलेक्ट नहीं कर सकते हम। सिमिलरली अगर आप इस पे जाओगे तो आप 0 से 0 स्टार्ट कर सकते हो। इसका 0 प्रॉब्लम इसको नेक्स्ट में और उसका नेक्स्ट स्मॉलर कुछ है नहीं तो आप कुछ भी सिलेक्ट कर सकते हो। 0 से स्टार्ट करोगे आपको माइनस कि आप कहाँ स्टार्ट कर सकते हो और कहाँ एंड कर सकते हो। इसमें से कुछ भी रीजन सेलेक्ट कर लो। Yeah, so I have actually trimmed the part where I was solving the fifth question. So it's because the video was getting insanely long, and also it would have been like watching another 30 boring minutes of the stream. So yeah, I'll share the editorial of the problems that I was able to solve during the contest. So yeah, the first problem is this: the beginning era of cyberverse. So what the question actually tells you is that it's a pretty long statement, and what it actually means is that you have an array of n size, right? And you have, let's say, a number k. So what you need to do is you need to assign some part of this k to every index of this array, and there are n indices. There is one condition that the maximum value minus minimum value should be less than equal to 1 when you assign all these values. So yeah, like that's pretty standard. What you can do is you can assign n by k first of all to all of them, and then there will be some remainder, so that will be n modulus k. Now this remainder will definitely be less than n. So what you can do is you can choose these many indices and assign one extra number to that, and in this way you will have the minimum value as minimum. Like also the question wants you to assign in such a way that, such that the minimum value that you get, it should be the minimum possible, right? Minimum possible. So yeah, the minimum value will definitely be n by k. So yeah, that is the answer for this one. Yeah, so like it was pretty easy one, and it was fine to be an A problem. Next, you have this question called Sib alphabet, and this was a fine problem, I would say. So what they've told you is that the problem tells you that you can assign, you have an n string, this is n, and this string should contain lowercase letters, so it should be like a b c something. And what it has also told you is that a corresponds to 2 to the power 0, b corresponds to 2 to the power 1, similarly z corresponds to 2 to the power 25. So what happens is whenever you assign a value, what you actually want is that the sum of the whole string should be exactly k, right? So now the minimum value that you can assign to any index is 1, and the maximum value that you can assign to any index is 2 to the power 25. So the minimum value that you can achieve is definitely n, that is 1 into n, and the maximum value that you can achieve is 2 to the power 25 into n, right? So if k is below this, if k is less than this, or if k is greater than this, then in that case the answer is simply -1 because you cannot form that element there. Now the thing is that all of these values in between are reachable. I mean, it is like very intuitive. I don't have valid proof for this, but yeah, I kind of visualized it. So that is it. Like all these values in between are reachable. So what I did was I simply started assigning. I did not maintain the whole string. I first made a string that was the smallest string that actually corresponds to k. Like I started assigning the maximum values. For example, if I'm able to assign a z, I assigned a z and I subtracted 2 to the power 25 from k. Now in this way, I actually constructed this string greedily, and by doing this, what happened was this length may be now less than n. If it is greater than n, then we definitely know that the answer isn't possible, because this is the shortest string that can be made. But this case would have been already covered in this case when we were saying that when k is greater than 2 to the power 25 into n, then you print -1. So that would have been covered there only. But I had handled it differently in my code. So yeah, moving on, what I did was first I have this greedy string, which is the shortest possible, and let's say its length is n1. So n1 is less than equal to n. Now if n1 is less than n, what I have to do is I have to, increase its length so that it becomes n, right? So what I did was I started picking the maximum character that I already have. Let's say I have z, and I split it into two parts. Like when I split a z into two parts, what I can do is I can put a y and a y. What happens when I do this is, the sum remains same, but I've increased my length by one, right? So this way I simply pick the last character from the end, and I keep removing it, and I keep putting two characters that are, just behind it. For example, if you have b, then you put two a's. So like, yeah, this way what happens is you can construct the whole string till your length is not n, and I can show you the code for this one. I have used a multi-set which makes the complexity n log n, but you can do it in order of n by maintaining frequency arrays, because there are at max 25 different values. So what I'm doing is, first I'm constructing the greedy string. I'm storing all these in a multi-set, and then I start picking up the maximum value from the end, and I erase that and I insert two values behind that, and in the end I eventually print the string. Right, so that was it for this problem. Then this is the third problem, which is angry cyborg. And so yeah, what the question tells you is, what happens is that you have an array, and let's say all of these values are 0. So you have like all the values are zeros, right? So what you do is, you're given q queries and you have L to R, and what it tells you is that, you add 1 to L. Let's say L is this and R is this. So you add 1 to L, then you add 2 to L plus 1, then you add 3 to L plus 2, so on up till R. You keep doing this, and you add R minus L plus 1 at the Rth index. So what it tells you is that, you get so many queries, and at the end you need to print the final array, right? So you could have done it with some lazy propagation and segment tree as well, but what I did was this. Like, I maintained fenwick tree. So what I'm doing is, I'm doing range updates, and then I'll be doing point queries. So what I'm doing is, if they say that, you have to add L to R, so what I do is I add only 1 to all of them. Now what happens is that when I construct the final array at the end, what I'll do is I'll pick this index and I'll assign 1. Then I'll pick this index, I'll add 1 to the answer, and then I'll also add the answer that was behind it. So here it becomes 2, then it becomes 3, and so on. It becomes, let's say, R minus L plus 1 here, like that. But we don't want it to propagate further. So what I'll do is, at this index I'll assign simply minus of R minus L plus L, just a minute, R minus L plus 1, yeah, R minus L plus 1. By doing this, I'll have this in this number here, and when this number will get added to this one, it will get neutralized, right? So yeah, what you can do is, you can maintain a fenwick tree, and you can update this range, and you can update this point as well, and you can consider it as a range only, like an, I comma I range. So you can update this also. This can be done with a fenwick tree, and at the end you simply calculate the sums, and you keep adding the sum that was at the previous index, right? So I can show you my code for this. So here what I'm doing is that I've made this bit, the binary index tree, and then I've taken L and R, and I'm updating in the range, which is from, first I'm updating in the range L to N, and this is simply assigning 1 to all of them, and then I also assign minus 1, which is like pretty standard for a fenwick tree. It is exactly how you do a range update in a fenwick tree. And then at the next index I'm assigning this value, and yeah, to neutralize it, I'm assigning it to the next index. So at the end, I simply sum up the prefixes and print it. And this is the code for the update and query of the fin victory. So yeah, that is it. I'll move to the next problem now. Right, so moving on to the next problem, this is rise of cyborgs. And what you need to do in this problem is that you need to calculate something called as a range minimum for many times. Like you need to do it for order of m square times, where m is the length of the array B. So I'll show you what exactly needs to be done here. Let this be an array A and B. So what you do is you select two indices from B, let's say I and J, and let's the values x and y, and then you go in the array A and you go to the xth index, and then you go to the yth index, and you calculate the minimum in this range, and you basically add it to your answer, right? So you add it here, like whatever is the minimum value, you add it to your answer. So you need to do it for all the possible pairs of I and j. So the number of possible pairs of I and j is simply order of m square. So if you go about solving it with a brute force way, you can do like order of n square pairs, and calculating the minimum can be done in order of log n if you use a segment tree, and it can be done in order of n if you use something called as sparse table. But still, this is pretty slow. Like order of m square simply won't work because m is in the range of 10 to the power 5, 1 to 10 to the power 5. So this won't work. And another interesting way of approaching this problem would be, you go in the array A and you calculate the contributing factor for every AI. Like if we can calculate the number of ranges for which AI is the minimum value, and you simply add AI that many times, then you'll get your answer, right? So what we can do is, what we're also given is the array B is increasing. So let's say I have AI, and let's say AJ, and we have AK, where AK is the previous smaller element from AI, and AJ is the just next smaller element from AI. So what you do is you have to select X and Y here, right? How can you select X? X should definitely be greater than K, right? And X should definitely be less than equal to Y. Similarly, Y should be definitely less than J, and Y should be greater than equal to Y. Why is this so? Because if you select X, let's say you select something X is less than equal to K, then what will happen is your X will shift somewhere here, and then the minimum will not be AI, then the minimum will be AK. So, and similarly for Y, if you choose Y, let's say Y is greater than equal to J, then your Y will shift here, and then your minimum won't be AI, it will be AJ. So these are the conditions for X and Y. So what you do is you have an array B and you have X. So we are saying that X is less than equal to I, and X is greater than K. Similarly, Y is greater than equal to I, and Y is less than J. Now searching in the array B, like how many X's are there such that this condition holds, this can be done in order of log n using binary search, and similarly this can also be done in order of log n using binary search, log m to be specific. So what we are doing is the whole complex, and then we'll simply multiply. Like let's say this is P, the number of X falling in this range are P, and the number of Y falling in this range are Q. So we simply add to our answer P into Q into AI, and we do it for all the i's. So our whole complexity then becomes order of log m into n, because n times we are doing this. So yeah, and this will work where m and n are both in the range 10 to the power 5. So this will work, and yeah, that is the solution. I'll show you my code for this. So yeah, this is my code. What I'm doing is, first I'm calculating the next smaller element and the previous smaller element. And this is a pretty standard problem. You can do it using a stack. This can be done in order of n. Computing both of these is order of n. Then what I do is I calculate the start value. yeah, like previous smaller, the x has to be greater than k, and k is like the previous smaller, and also the like the y has to be less than j, and j is basically the next smaller. So that this is what I'm doing, and then I had handled an intersection case. Like this is not required. If you look at the if you look at the constraints and read the statement properly, this will never occur. Like what I'm also handling is like if the ranges of x and y they intersect, then what I do, then I'll have to subtract some of them, right? But this case won't occur anywhere in this question. So even if you don't handle the intersecting part, that's fine. So all of this is like zero. It will only add zero to your contribution. So yeah, that is it. Like this was the problem. And yeah, moving on to the next problem. This is the last problem that I could solve during the contest, which is cyber T. Now, this is also an interesting problem. Like, if you can visualize it, it's like a pretty cool problem. So, what they're telling you is you have a tree and you need to consider all the BFS traversals that you can have for this tree. Like, and for any BFS traversal, you know that first of all, the nodes which are at the level less will occur first. So, for example, if we have for the level 0, we have only one node. Then for level 2, these can occur in any permutation. These two nodes can occur in any permutation. Similarly, these four nodes can occur in any permutation, right? And then these can occur in any permutation. So like, yeah, you need to consider all of that, but all of that is not required because what they're telling you is, let's say you have this array constructed A for the BFS traversal, and what you need to do is for every index I and j, if I is less than j and if ai is less than aj, then you add 1 to your answer, otherwise you subtract 1 from your answer. So basically, like, you need to calculate the number of non-inversions. The number of non-inversions you add number of, or basically you can say it like this, you subtract the number of inversions at every point and you add the number of non-inversions, and they want you to calculate the expected value of all the possible arrays A that you can construct from this BFS traversal. But an interesting thing to note here is that, since we are considering all the permutations here and all the permutations here, all the permutations here, but if we consider any element from this level and any element from this level, their order won't change anywhere. So like if we have AI and if we have AI and if we have AJ and the level of AI is, let's say, 1 and the level of AJ is greater than 1, so their order will never change in any permutation. So what you do is you calculate their answer. If AJ is greater than AI, you simply add 1 to your answer. Otherwise, you subtract 1 from your answer. Like this, this is pretty like standard way of doing it. But then, how do you calculate the answer for all the permutations? Now, what happens is when you calculate all the permutations and you look at all the inversions and then you look at all the non-inversions. So like every pair, every pair in this permutation can be an inversion or can be a non-inversion, right? Like there are only two possible ways a pair can occur. It can be an inversion or it can be a non-inversion. But if you consider all the possible ways, then the expected score that will get added will definitely be 0, right? Because if at some point it is an inversion, then you're adding 1. Like if at some point if it is a non-inversion, then you're adding 1, and if at some point it is an inversion, you're subtracting 1. So like both of these cases will occur equal number of times, right? When you're considering only the permutations for a specific level. So the contributing factor for that will be 0 only. So the question basically reduces to, like, I'll show you my code for this. It basically reduces to finding all the values in a specific level, and if the level of an index is greater than the level of another index, then only you add or subtract your answer, otherwise you don't do anything for that. So what I'm doing is I'm calculating the level of every index here, and then for every level I'm adding the numbers that are in that level. And I've maintained a PBDS, but you can do it using a set or anything like that. Then I calculate the number of values that are less than this, and I add that to my answer, and I calculate the number of values that are greater than this, and I subtract that from my answer. And then yeah, I add all of these values to my PBDS. So yeah, that is for the editorial of the problems that I was able to solve for this round. I hope you like the video, and if you do, please consider liking and subscribing to my channel. Also, you can leave out comments for any problem that you want me to, explain more about. And yeah, that is it. Goodbye then.